Um, okay. Hi everyone. I hope you hear me. If you hear me, then please tell me, cause like, yeah, it would be good to know that I am heard. That's nice. That's nice. Uh, so we'll be talking about all problems from A up to E1, cause well, as some of you may friend me on Codeforces, I haven't solved D, but actually I have solved it. I didn't have enough time to implement it, right? Because I was pretty slow and also I got late to contest. So yeah, but I'm sure that I solved it. Like mine solved it. If you want, I can debug it on stream. Like if we can do it in the end if somebody likes seeing such things. Then yeah, we can do it on stream. And yeah. So we'll wait for like I think 3 more minutes or something, so everybody can come. Yeah, I'm sorry for no face cam. I wanted to turn it on, but I don't know if you will see it. Like, wait, maybe you. Oh, you see it. Like it's completely booked. Like I completely don't know what's happening. My camera, like it stopped working. I don't know what happened. OBS is hard. Oh wait, yeah, it's very weird. And I don't know how to like make it work. Somebody said to me, yeah, exactly, it's frozen. Like I don't know what to do with the fact that it's frozen. Uh, Read the top message. That's what Raj Sarkar said. Hey, I'm currently at 752. I did 5 wrong submissions, so 200. I have seen your videos about tips to new users, so as you said. You should join, but I should join you to a different. Uh, I don't know. Oh, and also, please welcome, Even Value, sir. He is on chat today. He's Giga Chat from India, you know, like so strong, so strong. Yeah. And friend him, cause like he should be our idol. Like he was expert back in November, and now he's like almost grandmaster. It's only a matter of time till he will get to grandmaster. So it's an easy choice. You start him and you get like plus 200 rating. Yeah, so friend him. And also I heard that he really likes when you go and send him a message, Also his nick on Discord is also even value, so try to friend him. Yeah. Okay. So now we can go to the problems. I'm from Poland if somebody. Yeah. If somebody wonders, I'm from Poland. Let's go to the problems. As you can notice, problem A was the hardest problem in today's contest. Maybe it was harder, but for sure all the problems from B to E1 were much easier than A. A was by far the hardest, but we'll start from A because, yeah, that's what we'll do. We'll start from A, even if it's the hardest problem. At least for me, it was by far the hardest. Yeah. So, in this problem, we are given a number n, and we want to construct such a string consisting only of letters A, O, E, I, u. We want to construct a string consisting of only those letters, such that the number of palindromic subsequences of this string is as small as possible, right? We want this number to be as small as possible. So what is the subsequence? Well, for example, if you would have a string A, O, O, A, U, I, A, then a subsequence is like we take some of the letters in the order they are in the string, right? Like it is just like, I don't know, deleting some of the letters and leaving the rest, right? And this would be the substring AAI, right? And what is a palindrome? I will also remind you. A palindrome is a string such that it's the same from left side and the same from the right side, right? If you would read it from the left side, it would be kayak, and it would, if you would read it from the right side, it would also be kayak, right? You can see that. It's the same reading from the left and the same from the right. So now we want to make a string such that we have as small amount as possible of those palindromic subsequences, right? So how we'll do that? First we can notice that, let's look at the multiset of the letters that we picked. Let's say that this multiset is A, B, 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 and E. Oh no, we can't pick B, sorry. O, and E, E. So now we can notice that we want to order those letters in some way, right, to get our string. We can notice that the lower bound for the number of palindromic substrings will be sum over, let's say that the number of A's that we have is count A, the number of O's that we have is count O, and the number of E's that we have is count E. We can notice that, let's say that we order them in some way, and our E's are somewhere here in our string, right? And between them there are some unknown letters, the letters that we don't know. Then we can notice that no matter what letters we'll pick between E's, all of the subsequences containing only E's are palindromic. Because everything that contains only one letter is palindromic, right? So we can notice that, like, for each letter, when we have, let's say, X of some letter, then we have X choose two possible, we have X choose two possible subsequences consisting of only this letter, right? Because we can take every interval of E's. We can take this interval or this, right? It's easy. So we can notice that for some multiset, it will be always optimal to just achieve lower bound. Because we now have shown that our lower bound will be like the amount of subsequences consisting of only one letter, right? One different letter, sorry. So we can just order them like this. We can just order them A, O, E. And this will be optimal because we know that we can't get better than this, right? Like these subsequences A, or something, they need, no matter how we order them, they still will appear. So now we know that we know that we will order them like this, right? So now we only want to find how many of each letter will be there. So we see that it's intuitive that it will be optimal to make the amounts of letters as close to each other as possible. Because our sum looks like this. It's like, our cost looks like this. It's like count A, choose 2, plus count O, choose 2, etc. So we can see that we want to make those counts as close as possible, because it's always like this when you add something that is quadratic, right? And when you add something that is quadratic, and so when you want to minimize the sum a squared plus b squared plus c squared plus z squared, and you know that a plus b plus c plus z, it is some constant, then you want to make them as close to each other as possible. And those are, well, those are not exactly squares of them, but they're close, right? They look the same. So, well, we'll just make them as equal to each other as possible. So we will take n divided by 5, because we have 5 different letters, as you can see here, right? 5 different letters. N divided by 5, n divided by 5, n divided by 5, and n divided by 5. And then everything, of course, with a floor. And then possibly there will be some, then possibly our string will still be too short, so we will add 1 to some of them, right? So this is as close to each other as possible. So do you have any questions? Well, we are choosing 2 from count because we are looking like, wait, have I trolled? I may trolled. No, because this will be probably 2 to the power of count. You are right. Yeah. Still, you will want to make them as close to each other as possible. Let me... So yeah, you were completely right. Let me... wait, let me fix my mistake. So it's 2 to the power of count A plus 2 to the power of count B plus 2 to the power of count C. Yeah, and count O, count E, etc. But it still works that you want to make them as close as possible, right? Yeah, exactly as Infinite Codes was saying. Still the solution stays the same. Yeah. So, do you have any questions now? Why did you choose the particular arrangement of keeping the same characters together? Okay, because you can notice that if you pick some characters, you didn't order them yet, but you picked them already, then you can notice that for each group of characters that are the same, you will have to add all 2 to the power of count of them substrings, right? Because if you have some A's, or some E's as I showed here, and there are some letters between them that are not, you don't know anything about them, then all the subsequences of those E's will create palindromic subsequences, right? So we know that no matter how we order them, we will always add 2 to the power of count A plus 2 to the power of count O plus 2 to the power of count E, no matter how we order them. So if this is our lower bound and we can get it, then, well, we want to order them such that we get it. And we can see that if we order them like AAA, OOO, and EEE, then the only palindromic subsequences are of the form the same letters, right? There is no palindromic subsequence here such that it consists of 2 or more different letters. This is not palindromic. So, do you understand now? Yeah, so let's go to next problem. Or does anyone have any more questions? I think that should answer your questions. Yeah, okay. Let's go to B, I guess. So yeah, let me go to B2, because B2 is like, I don't know, it's the same. So in this problem, we are said that we have a number line, right? In problem B, we are given a number line spanning from 1 to n. We can't go out of it. We can't. And there are m bad teachers. Let's say that they are somewhere here. There is also one hero of ours. And let's say that he's somewhere here. In one turn, first our hero may move 1 to the right or 1 to the left, or he can stay in the same position. And all of the teachers can move or not move. Right? We want to say for the fixed positions of our teachers and different positions of our hero, what is the amount of moves? How many moves the teachers need to catch this blue hero? Do you understand it? Like, do you understand the statement? Okay, so now let's start by solving B1 when you have 1 student and at most 2 teachers. So, if you have a student and 2 teachers that and you have a student and 1 teacher is left of him and 1 teacher is right of him, then you can notice that the student can always go to the side in which the further teacher is, right? So the student will always go to the side of the further teacher, right? Or I don't know, you can just notice that until the distance between teachers, if you have a situation like this, right? So you have 1 teacher and another teacher, and between them there are at least 3 cells, like between them there are at least 3 cells. Then if our student is between them, he can always escape them, to not be killed in this move. And by induction we can prove that he can always do this, right? He can always do this. So, yeah, we can just notice that the distance between teachers always gets smaller by 2, right? Because this teacher will go to the right and this teacher will go to the left. So, our student can keep escaping as long as the distance is, well, greater than 0. If the teachers meet, then they had to eat our student between them, right? So, if the distance between our teacher to the right and our teacher to the left is d, then we know that our student will be able to escape like d divided by 2 times upper bound from this. Yeah. So, somebody asked, oh no, that's not to me. So, we already solved B1, right? You just see out distance by 2. So now we can notice in B2, also there is another situation, sorry, when both of the teachers are right to me. Let me show this better. If both of the teachers are right to me, then we can notice that I will always run to the left and stay there. So then we can just see out the distance of this teacher are -1. Like the distance to this teacher to the beginning. Because I will always escape here. Or, so yeah, I will always escape to the most left and wait there. Or the other case is like this. And in this case, I will always escape like to the right and wait there. So in this case, it's n minus L. It's distance that this guy needs to go there to catch me. Oh, you are right. You are right that this will be floor. I'm sorry. Yeah, you are right. This is floor. Exactly, because if the distance is 1, they already cut him. You are completely right. Mr. Shlupka or something. So now B2. Let's solve B2. In B2, we have more teachers. We can notice one simple thing. We have many different teachers here and here. The only two we care about is the one that is first to the left of me and first to the right of me. Right? So for each cell we can calculate what is the teacher that is first to the right of me and first to the left of me and just solve B1. And that's it. Or we can use set and like lower bound. I don't know how you prefer. To calculate first to the right and first to the left, you can do just some simple DP or I don't know if to even call it DP. Just like when you calculate right from E, then it's either I if there is a teacher here, right? If there is a teacher here, then the first teacher to the right is me, or it's right from I plus 1 if there's no teacher here. It's easy. So, do you understand? But do you have any question? Cause like the last part you mean B2? You mean B2? Okay, so we already solved if we have exactly 2 teachers. So now we can notice that, well, when you have more teachers, then we just don't care. We just don't care about all the teachers that are like far from me. We only care about the teacher that is like first teacher to the left of me and first teacher that is right to me. Right? And we can just solve B1 on this. That's it. And Prasad TGS asked if this is minimum from left -2 and right -2. No, it's not. It's not. Because for some time he may escape the first guy and then he may escape the second guy. Yeah. So, up to C, I guess? Or do you have any more specific questions? Okay, let's go to C. Because I don't see any questions. Okay, C. Like, I don't understand what you mean. Can you tell the notation like this for B? I don't understand. Let's go to C. Yes, it was C hard for its place. I think it was normal for its place. Like 2,000 people maybe got an accept on this, so this was like a normal C. Yeah, so like in C you have some strings. Let's copy this example. And you can pick some subset of the strings. So let's say, okay, let me pick some good subset. Narek. Okay, let me pick those two. And now we look at the concatenation of those strings in the order that they are on input. So N, R, 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 A, R, A, K. Okay, let me copy this 2 times because like I'm not good at handwriting, as you see. Wait. So we look at the concatenation of these two. So yeah, as you can see there, yeah, they are concatenated, right? You have a plus here. They're bonded. So now what we do, we want, in this concatenation, we found as many subsequences Narek as we can, right? We know that in this type of questions, the greedy works. So we take the first N, the second A, the first N. First we take N, then we take A, then we take R, then we take A, then we take K, then we take N, A, R, E, K. Okay, so each letter that we take, we add to our answer. So our answer is 10. But each letter that we don't take, like this R, or this R, or this K, each letter that we don't take, but it's N or A or R or I or K, we subtract. So we won't subtract Z because it's not one of our letters. So yeah, it will be 10 minus 3, so 7 will be our answer. So over all concatenations, we want to find maximum answer. Right? So let's solve. We just do simple DP. DP from cause it's a good question. Why isn't it 10 minus 4? Cause we only subtract the letters that are N or A or R or I or K. If Z is not one of those 5 letters, then we don't subtract. Yeah, we only count letters that are in Narek. Other letters we don't care. So now we can just do DP from the letter that we start. So it will be DP from N, A, R, E, and K, from the position in those strings, right? So, for example, we can start from this position, right? And this will be like position 4, 1, because this is fourth string and first position. So from I, the number of string, and J, the position in that string. And how will our calculations look like? When we are in some string, let's say we are in some string on position, we are on string 4 at position 3. So there is some string and we are at this position and we want to calculate it starting from, let's say, A, right? Then we are looking for the first A, right to it, because as you saw here, we want to greedily look for them. So let's say that first A is here. And well, it's easy to calculate how much we'll add, right? It's just it is just like how many unused letters are here. So there might be some N, there might be some N, or I don't know, K's here, and we have to subtract all of them. We add this one, and well, we add dp from this guy here, right? We'll add dp from, if we had from A, we'll add dp from R, because R is the next letter, from I, from J, right? And the other case is that, well, there is no A right to me. What does it mean? What does it mean? It means that I have to concatenate new string to me. So then I look at the maximum from dp from R, from I, from 1. That means that I start a new string, right? And this is how our dp changes. That's basically just it. You can try to write the formulas yourself. But yeah, that's basically just it. Do you like idea of the dp is that we are assuming that we are at the position of our concatenated string that was before concatenation the jth position of the ith string, and we are looking for letter A, or we are looking for letter R or E, right? Those are the three things that we are keeping in our dp. Starting letter, number of string, so like string, and position in it. Do you understand? Unquovical Love asked, can we have two states like the index I and index j of the string Narek? And if j exceeds the site, we reset it to 0 and continue? I don't understand. So could you ask it one more time, or maybe some other person has a question? Can you explain recursive dp? I don't understand that too. Like, what do you mean by can you explain recursive dp? I think dp with Mimo was already explained on the channel. Oh, why we need starting char one? We probably don't need... Like, we need it, because, like... Okay. Let's look at it like this. We are looking at our concatenated string, right? It is formed by concatenating some strings. Then we want to calculate the answer and what letter we will end on for this string here, right? But to calculate it, we need to know which was the last letter that we marked. So for example, it will be different if we already have Nare formed, and it will be different if I just have N, right? It will be different. So that's why you need it. Like, to know how your greedy will work, you need to know which letter you start on. So I've had a tiny crash of OBS, but we are back. So do you have any more questions? I learned DP on my school class, and like I was starting to learn DP. We have like those workshops, or I don't know how to say it in English, in Polish. Don't you need another array of possible? Because otherwise you would have the sequence Narek and count it as 5. Why would I count it as plus 5? Like in the beginning my answer at the end will be maximum from dp from n11, dp from n to 1, and etc. So I'm assuming I start at all strings, and from 0, of course, because all the answers can be smaller than 0, possibly. But yeah, I think I know what you mean. You mean that, for example, we could get Narek, or we could get Nare, but we wouldn't finish it, and we would get it as plus 4. So yeah, you can solve it by, you have many ways to solve it, but I did something like basically I started each dp at like negative value, and then I max it further, but it has to be negative value at the beginning. Because what does it mean? What does it mean, that negative value? That means that, let's say that I have my dp, right? I finished at Nare. I can't get anything better. But this dp here needs to take some other dp. So I say that like dp from n plus 1 from dp from n plus 1, dp from k, so from the last letter, from n plus 1, from 1. So like if I don't concatenate another string to it, I just say that there is a fictional string n plus 1, this dp will be equal to minus 4. That will mean that, sorry, I think -4 or -8. And it depends how you implement it. It will be -8 or -4. But I have -4. So that means that I subtract all those numbers. If I don't manage to go over the line and concatenate something different to finish it, then I have to subtract this 4. So, yeah, that's it. I think let's go to another problem. Or do you have any questions? Let's go to another problems, I guess. Or do you have any questions? Okay, I will explain it one more time. Like, it's hard to handle this case. Like, I already added to my answer and Narek, right? In my DPs in the future, I will add those 4 letters. So, what I do, if I don't concatenate a string after this, that means that I take some DP from n+1 from 1. This is some fictional string that I take from, right? DP from n+1, 1 means that I don't concatenate anything further, right? Because I always have to take from some DP. I always have to concatenate something next. If I don't concatenate something next, that means that I concatenate n+1. Because n+1 is just, well, n+1 is just fictional string that I always concatenate at the end. So now, if I finish needing k in this n+1, 1, then I subtract 4. If I finish needing e in this guy, then I subtract 3. That means that I added 3 more than I 3 more than I had to add, right? If I finish at r, then I subtract 2, etc. This is just it, basically. You always assume that you put this fictional string in the end. And this fictional string will subtract from us as much as we need. Do you understand it, unequivocal love? That's nice that you got it. So let me take like half-minute break because I need to drink some water because yeah, I'm really thirsty. And I'll be back in like half minute. Oh, so as you can see, my camera unlocked, so now you can see my face. I heard that Indian girls love me. That's what Naveen said to me, so don't treat me as a racist. It's all this guy is Indian and he told me. Okay? Yeah, I'm from Poland. But like it's I don't know any Indian girls. Naveen told me this, okay? So let's solve D, right? because we already solved A to C, and now it's time from D and T. After those problems C and A, you will be amazed at how easy E1 was. It was much easier than A and C. Okay. Navin says that this is misinformation, but as we all know, it's not. So, let's solve D. So, in this problem we are given two arrays. D. We are given two arrays. And we can make one move. I don't know if we have to make it. Yeah, we have to make one move, and move is like this. We pick an interval of those two arrays, right? And we swap those two intervals with each other. So the arrays that we'll get is A1, B2, B3, B4, A5. Here will be A6, etc. up to AN. And here we'll get B1, A2, A3, A4, B5 and up to Bn. Right, so we kinda swapped those two intervals. We just swapped those two intervals. And after this swapping, we calculate the GCD of our new array A, we calculate the GCD of our new array B, and we just sum them. Right? And we want to calculate two things. What is the maximum sum of these GCDs that we can get, and how many intervals give us this maximum, right? Do you understand statement? That's cool. So, in problems with GCD and intervals, you have one very strong observation that always works. No, not always. You have different, but in many times it works. Like observation always works, and it's many times it's crucial. Okay, so the observation is like this: when we'll look at some AL, and when we'll look at all the intervals starting here, we want to calculate the sum of GCDs for all the intervals starting in L, right? Up to AN. And here we have BL, BL plus 1, BL plus 2, BL plus 3, BL plus 4. We can notice one thing. How many different GCDs those intervals can have? How many different GCDs those like intervals starting at L can have? Yeah, Navin forgot that. Mr. Even Value, sir. He forgot that. How to be so strong and forgot. So, yeah. Well, how many different GCDs can we get there? Log. Why? We can use the fact that GCD works like this. GCD from A1 or AL plus 1 up to AR. What is it? It is GCD from AA plus 1 up to AR minus 1. So like we take the prefix before that and we add AR. What does it mean? It means that our new GCD is a divisor of this one. So if we are writing each GCD, so we'll write GCD from L, GCD from L plus 1, etc. up to GCD from R, you can notice that every next GCD is a divisor of previous one. So like, if I am a divisor and I am different than the previous one, I have to be at least 2 times smaller than it. Right? So if this is A and this is either A or something at most A divided by 2. This have to be either the same or something divided by 2 or even more. Right? Okay. So the same will of course work for B. So now we can notice that when we swap our 2 intervals, we only care about the GCDs of both of them. Right? We don't care about the elements in them, we just care about GCD. And the proof will be the same, right? Because like GCD, we only care about GCDs of them, okay? And, well, look how many different GCDs do we have here? 2 times log. Because we have log different GCDs from A and log different GCDs from B. So if we look at our L, and the blue intervals means like intervals of GCD in A, and red intervals mean intervals of GCDs in B, right? So we can notice that we only need to, our candidates will be this interval. We just need to look at every end of intervals, okay? Our candidates will be like just all the ends. So, yeah. So, now what we can do, we can just with some segment tree, or if someone prefers with sparse table, we can just check all those intervals. Right. Those will be like, not intervals, this will be groups of intervals. So for example, we will say that for here, we'll say that for each R from each R from let's say 1 to 3, our GCD of A is equal to something and GCD of B is equal to something, right? So yeah, we just calculate our new answer using sparse table or segment tree after swapping, or yeah, or we don't even have to do this, because like we can calculate prefix, GCDs and suffix as you prefer, and then we just, you know, look at all the candidates. So, do you have any questions? And yeah, do you have any questions? Okay, I don't see any questions, so I don't hate Indians, as someone said in the chat. I really like Indians, and yeah, my English pronunciation is really bad. I can't even say the word pronunciation good, and I'm from Poland. Not all Polish people have this bad English pronunciation. I just have bad one. So I don't see any questions. Like, I will repeat myself maybe once. You want to look at the group of intervals, right? And you want to notice that you have just n log n different group of intervals. We say that two intervals are different if they have different GCD in A or different GCD in B, right? And as I shown before, there are just n log n such groups. So yeah, we can just check them. Okay, so now I guess to E1, because nobody asked any questions. If you have some, or Navin has some to, then Navin has some to help me explain better, then yeah. But I don't see any questions. So let's go to E1, I guess. So let's go to E1. So in this problem we are given an array. And we are given a grid. N by m. And in each square of a grid, one of those numbers is like put, right? And now the players play the game on grid. The first player chooses some square of a grid equal to A1. So let's say this one. And then the second player will have to choose some square from this subgrid. Then if he picks A2 from here, then the third player the first player will have to pick from this subgrid. So if the player picked from the square ij, then the next player will have to pick from the grid starting in I plus 1, j plus 1, right? Ending at nm. We always have to, like, the first player will first choose A1, the second player will then choose A2, the third player will then choose A3, the fourth player will then choose A4, etc., right? And the player who is unable to make a move because, well, the array ended or the grid is empty or there is no number like this in the grid, he loses. So now we want to say for the first player, does he have a strategy to win? So in the E1, because I don't know how to solve E2, I didn't have any time to think about it because I just solved E1 and just rushed to D. That's bad that I haven't managed to solve it. In this we see that we have so small L, N, and M that we can just do simple DP L times N times N, right? This is our complexity. So what will this DP be? Looking at the submatrix starting from NM, so we are looking at some submatrix starting, let's say here or something. Assuming that now we have to pick some AI, so I. This means that now in the turns are starting from AI. Who wins? Or is this position winning or losing? Right? Because position can be either winning or losing. So we have our grid. We have our subgrid, NM. Our subgrid NM means that we are starting from some, this is our subgrid, right? NM. We are starting from some square A. Well, wait, let me call it better. We are starting from some AB subgrid, right? So here's AB. And now we want to check if we can make some move to make this position winning or to win. What would this mean? We will pick some square where AI is written, right? Because we are starting from I. And then look if this next subgrid, this green subgrid, is winning. If this is winning, then well, our move was bad. Because we let our opponent win. So we want this subgrid to be losing. So we want to check if there is some AI here, such that its subgrid like down and right to it is losing. How to check it? We can just calculate it with prefix sums. We'll calculate it in like order of decreasing i's, right? Because our I is always taking from I plus 1. Because after we are making move on I, our opponent will make move on I plus 1. And yeah, that's basically it. We just want to, when we are calculating all DPs from I and then some A and B, we will just iterate over all possible squares, check if AI is contained there, and if it is contained there, and this subgrid here is losing, so if DP from, let's say that this square here is CD, if DP from C plus 1, from D plus 1, from I plus 1, because we already made a move, if this is losing, then we found a good move. So we can find all the good moves because, well, this is a brute force, right? We can do n times L. We found all good moves there, let's say here, 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 and here. And now we are looking at some subgrid. How to find if there is some losing move that we can reach? Well, just do prefix sums to D. Just check if there is some move contained in this subgrid that we can make. And that's just it. So, do you have any questions, or maybe, yeah, do you have any questions? I don't know why there was this 7 here. I really don't know this. I don't know. So, do you have any questions, or because I haven't yet finished debugging my D, so do you want me to debug my D on the stream, or after the stream do you want me to finish the stream? I think it won't be very hard looking at how many people got it, because like if you will see, if we will look, already 128 people got it, so it won't be really hard, I guess. But I would need probably 20 or something minutes to solve it. And I don't have that time. So, do you have any questions, or do you want me to solve D on the stream, or like debug my D on the stream? Because as you can see, it gives like, yeah, it gives like bad result on the first one. It gives 9 for some reason. So do you want to see me debugging it or not? Maybe I will do some. Can I do? Oh wait. Yeah, so I made I hope somebody will answer my poll. Yeah, so if If you don't want to see this, you can answer no. I won't be like angry or something. Let's wait for more, because 3 people voted. Like, there are 20 people left on stream. The vote is completely anonymous. Like, I won't be angry or something. It's completely anonymous. Okay, it seems like you want me to debug it on stream. I don't know if I will be commenting this debugging. Like, it's not the best implementation. I know that I could... It might get tle even, because like, I did some things very bad here. Right? I could probably do it in like n log n, like pure n log n. Yeah, but I got like n log squared because I was really in a hurry. I started like writing it 10 minutes before the end. If you don't see it or something, then please tell me. Let me... you should see it though. If you don't see it, then tell me. Okay. So... I have 9-1 here. I don't know where I get 9. So I can try to check where I get 9. A means some answer. We have some candidate and we get the answer from him. So we can check like who the hell gives us 9, because 9 is very much. So I is our L, so it's where we start, and iterator will tell us where we end. Right? This is one of the potential endings. So, okay, let me also, for a moment, yeah, so 8 gives us 9. So for example, if we swap those two, it gives us 9, but we still have like 3 here. So I had to book my segment trees or something, because it seems very weird. Yeah, here it's like a completely absurd. Like, I don't know what I meant here. What the hell is even this? Like 3 from something 0 means that it's built on array A, and 3 from something 1 means it's built on array B. So like this was completely bugged segment tree. So now it's 2-1, which is kinda nice, but like, okay, it's kinda nice because like, as you can see, 2 is the good result here, but I still count the number of intervals bad. But here I can also do, if I just have my maximum, like if I don't get my maximum bigger, if I just have the same maximum, then I can just add it, the number of like new intervals that will come here. So let me see. Yes, it works on this test case. So let me see all the test cases. The second test case has the number, but the third test case is good. This one is small, so this one will be perfect to debug, because here he says that he can get GCD of 6, but my code only sees GCD of 3. So yeah, it will be perfect to debug because it's very small. So which one gives him GCD of 6? Oh, it's the sum of GCDs of 6, sorry. So he swaps the whole arrays, I see. So here he will get 1 because 13 is prime, and he will get 5. So yeah, it's 6. So this one will be useful now. Okay. I have like... Ooh, it seems bad. Because like my code says that those two things means like, if I start from I, when my groups of intervals are ending. So here they say that from 1 on to the infinity, all to the n, all the intervals on A are the same, which is, well, it's not right, because those two are different, right? So I messed up something here. And yeah, this is a book, because here should be I plus 1. Because we are iterating over like intervals from the next one to calculate me. It's kind of like dp. So it works, but it might destroy the other ones. Yeah, it completely messed up the other ones. Okay, so this one seems nice and small. Oh, third one, it has 2, 3 and mine says 2, 4, so that's nice. This one is very small too. So, this is the third one. As we can see, the answer here is 2, 3. Cause we can... How we can get... Oh yeah, 2 we get, cause no matter what we swap, it's always, no matter what we swap, both of those arrays will be coprime. No matter what we swap, all of those numbers are coprime, except from 14 and 8, but they're on the same index, so they will never be in the same array. So, no matter what we swap, it will always be 1, so we can look at all the 3 intervals. So let's now debug. And let's debug ITA. So let me look. Here we have 2, here we have 2, and here we have 2. So, okay, because our next will now have to be this. Yeah, I haven't updated. Like, next means when this group of interval ends. So when I'm going to like the previous group of intervals, then I have to also change the ending of this group of intervals. But this will only change the second line, and it's not enough. It's, or is it? Oh, it is. Okay, so let's submit. And let's see if I get accepted. No, I got wrong answer on test 2. That's very sad, actually. Yeah, so on some very, very big test. So I think let's write let's write a quick brute force using those things that I already have. I assume my segment tree is good. That you should not do this. You should just write like okay, I will write even bigger brute force. Yeah, I will write like a stupidest brute force alive, I guess. Okay, let me write the stupidest brute force alive. So we'll just take every possible interval and we will just calculate it very badly. Okay, you will see it, you will see it. So now what we'll do is we'll swap all of those guys between, swap AK, BK, and now our answer will be equal to get GCD from A plus get GCD from B. And if our answer is greater than our maximum, then our maximum is equal to our answer and our count is equal to 1. But if our answer is equal to our maximum, then we just have to get our count bigger and we'll do this. we also need to like unswap them, right? After each one we have to unswap them. Yes, so that's just it. We just need to write the function get GCD. So from, let's say, some t, and okay, let me fill them with zeros so it won't be stupid. Oh no, yeah, it can be done. So we'll iterate from 1 to n and just calculate our GCD using inbuilt GCD and return it. This is lambda function, right? I hope everyone knows this. And okay, let me see if it works on samples. It seems that it works. So let me write a generator. To this one it will be easy. We are assuming that we have one test case because we don't need more, and this is like easier to debug. N is from 1 to 5. And our numbers will be from 1 to 5 too, because it's easier to debug this way. Yeah, and that should generate different test cases with a seed. Okay, I have to see out the line here too. Yeah, this is how our test cases looks, yeah. So I have a script called test. It's already written. It can be 4, cause we can just swap them all and just get GCD3 here and GCD1 here. Right? So let me look at my code, I guess. Well, like, yeah, let me look at my code. And here it looks weird. Like, why is it the same for 1 and 1 here? Like, it says the same thing. Here it's good. Oh, no, it's good. It's good. Yeah, but the answer is calculated bad. Oh wait, did I troll? Because it seems like a troll now. It seemed like I trolled solution. Because this seems like a troll now, I have to say to you. I think I might troll the solutions. I will think about it later and tell you. But now we have to end the stream. Because I think I trolled the solution. You can look at the tutorial quickly. There is just video editorial. Oh wait. Yeah, well, yeah, I think this solution is trolled because, like, I was assuming that for some A, like the prefix that, like, when we choose an interval, it's not like the GCD of it, it's the only thing that matters. The GCD of prefix that left and suffix and prefix here and suffix here is also something that matters, right? The prefix will be the same, obviously, but the suffix will also change. So we also have to add to the candidates the different GCDs of suffixes, I guess. Because GCDs of suffixes also change. So that's something that we also need to get to our candidates. But that is easy. That is easy. That I can do. So let me do it. I will do it and we'll have accept. Yeah, that's exactly. I can take it into consideration. I also need to check different suffixes. So let me create some vector or set. Yeah, I won't implement it nicely, right? Suffixes a and suffixes b, and int gcda equal to 0 for int I calculate the gcda for all suffixes. Oh, sorry. And insert it into suff a. And I do this exactly same thing for b. If someone's eye hurt from like seeing me write super unoptimal codes, I'm sorry, but I like writing it like this. And here I have my candidate, so I will just iterate over suff a and push into my candidates, and suff b, and I will push them too into my candidates. And that should work. Okay, here I have suff b, not here should be gcda and gcdb. Oh no, I'm not compilating this one. Yeah, it was minor. It's 4.2 now. What the hell? Okay, cause I only need to insert those suffixes that are greater than me. Sorry? So if x is greater than I, then I have to insert it. And the same here. Else I can just break, cause it will be kinda... It's not needed. This break is not needed for this thing to work, but like, yeah, it may be crucial. Or no, it won't be crucial because it's just log here. Okay, so for code readability, I will leave this out. And the same thing here. We only insert those suffixes that are bigger than I, because like it's weird to have candidates that are like degenerate. So yeah, now it's working. Let me submit. It might get let. It's only because of constant. Its complexity is n log squared, right? I see that it was very slow here. So, oh, now it got red. Okay. Let me debug it some more, I guess. Yeah, I guess. Let me debug it some more. How can you get re? How can you get re, bro? So everything here seems not bad. Let me look. I don't know why this is happening. Yeah, the easiest thing, just use GDB when you have runtime error. 132. What? Okay, I know. I insert GCDB where I have to insert indexes, not values. That is super weird what I have done here. I need to check the previous GCD. Let's say that at the beginning it will be -1. And if my GCD is different than previous GCD, then that's what I'm going to do. I only want those first suffixes that are different. Yeah. Okay, so then I'm going to insert you. And my previous GCD, let's say call it previous. My previous GCD was different than this one. Yeah, and here previous is -1, 2. Okay. And if my previous GCD, if GCDB is different than previous, sec3 is probably not needed in this task. I just had like 0 minutes to think about the implementation, so that's why I have, okay, I still have a yes, because I should, if I would be smart, insert here I, but I do not do this. So previous equals GCDB. Yep, that's just it. It doesn't get segmentation fault now. It will get tle, I'm almost sure of that. How much time limit we have? We have only 4 seconds. Yeah, it will probably get tle. But you will see. We'll see. It got voila. That's very weird. Okay, I forgot to do longs here. But it may not get tle. If it doesn't get tle on max test, then it might not get tle. Yep. So now we are praying for not getting GCD, tle. Or tle, I don't know how it's pronounced in English. Okay, I feel this GCD, I feel tle in my bones. Or tle, I don't know, time limit exceeded. Let's see. Let's not get tle. Yeah, but it's not yet accepted. It can get tle. We can with high probability say that it won't get wrong answer now, right? It's like too many tests passed to get wrong answer, but it can get tle, or not mle probably, because I do not use much memory here. Yeah, I know Cheyenne, right? So yeah, he asked me to do the stream. So we are waiting. How many tests are there? Can we like check it looking at someone's submission? Okay, so there are 30 tests. So we're waiting for 30. 22 out of 30. 25. $26, $27, $29. What? That I am. Oh, yeah. Okay. So the time limit was 4 seconds, and you see my time. Thank you very much. Yes, sparse table would be much faster. I know that I could write it with sparse table, but I had like 5 minutes. Sparse table would probably be much faster. Yeah, try to hack it, Naveen. I dare you. I like changing it to sparse table is around 2 minutes of work, so I will be happy if someone would use their time to hack me. It would be like a great honor. So what can I say? I hope you liked it. There will be block with all the things in it, right? There will be block with all the solutions that I talked about too much. And what can I say? I hope you like it. If you want, there is @CoderDP beginner contest, but thank you for watching the stream. Stay tuned for more on this channel. Watch the streams if you like. Do competitive programming, and I think see you next time. Or do you want to say anything or ask any questions? To reach specialist, I don't think you need any topics. You need to do ad hoc problems, and that's it. Like, I don't know, maybe you need bean search, because bean search is easiest. Yeah. Bean search is like bean search and DP, I would say, if you want to say topics. Like bean search and DP are the only two topics that you need to know to like reach, I don't know, candidate master or something. Yeah. So, see you next time.